Watch this question. This is asked in GATE 2008. They are saying that there is enter critical section, leave critical section. There are two functions and which are used to implement critical sections of a process, and they are realized using test and set. So it is the question about TSL, test and set lock, and I told you about TSL. It is simply the lock variable where we are going to read the lock as well as set the lock as an atomic operation, so that there will be no preemption in the middle. So whoever reads the TSL will always see that lock value as 0. I mean, in the beginning, whoever reads it first will get the lock value as 0, and they are going to set the lock value to 1. So later, if anyone tries to see it, they will always get a 1 unless the first process makes it again 0, right? So they are writing code like this. Enter critical section is they are going to test and set x. So let us say x is a variable, lock variable. Then they are going to read the value from x as well as set the value to x as 1. That is the code. I mean, they didn't clearly specify it, but the meaning is they are going to read the value of x, which is earlier, and now they are going to set the value of x to 1, right? And now if it is 1, they are going to stay there, which means if the earlier value of x is 1, they are going to stay there, not the new value, right? And next one is while leaving, they are going to make it as 0. So this is same as the TSL which we have seen earlier, just the code is different, okay? And x is initialized to 0, which means whenever x is 0, people can enter the critical section. Whenever x is 1, the process should not enter the critical section, right? And now if this is implementation, nothing is there except that it is all about TSL. So they have some few questions about the TSL itself. It is no different from TSL, the earlier version we have seen. And the question is, the above solution to CS is deadlock free. So is this critical section solution, is it deadlock free? We already know that this lock variable or TSL will never cause deadlock, isn't it? Why? There is a chance that two processes might enter the critical section at the same time without TSL with the lock variable, but with TSL only one process will enter it, and only whenever a process looks at the value, executes TSL first, that is going to get the access, and all the other processes are blocked, which means all the processes are not getting blocked. One process is definitely going to enter the critical section, and when it leaves, it will enable the other process to enter it. So it is definitely not having any deadlock. So which of the following is true? The above solution to critical section is deadlock free. Yes, this is true. It is deadlock free. The solution is starvation free. What is the second statement is they are talking about bounded waiting. So what is bounded waiting? If a process wants to enter into the critical section, it should not be stopped for a long time. It should be able to enter it, as early as possible, or it should not stop forever. But because of this lock variable, it is not possible. See, you might feel that there is no starvation here, but I'll show you how the starvation is possible. It is very important. You will definitely feel that there is no starvation, but there is starvation here, and even many books have given the answer wrong. So how the starvation is possible here is, just watch it. Assume that P1 has taken the lock first, which means P1 is in CS, and then it got preempted, and now P2 got into the execution, and P2 wanted this, but it fell in while loop. So as long as it is in the CPU, it will be in the while loop for a long time, and after that eventually it will get scheduled out. So let us say the next one again which got scheduled is P1, and it exited and it came out. Therefore let us say here P1 has made again x equal to 0 and it came out. Then it is the next, let's say P3 got into execution, some other process, right? Now this P3, since it is x is 0, it has the liberty to get into and make enter the critical section, right? Now P3 is in critical section and P3 got preempted, and again P2 came into existence, right? P2 got scheduled. Then what happens? It will again come and fall in the infinite loop, and as long as it is there, it will keep on falling in infinite loop. Now let's say P3 again got scheduled after this, and it left the critical section and it made x equal to 0, and suddenly P4 came, and now P4 entered the critical section. Who wanted to enter the critical section? P2 wanted to enter the critical section, but then there is no way that P2 could say any reservation, which means P2 cannot say that I have been waiting for a long time, please let me go. There is no way it could say. Therefore any process can get into the critical section, and any unlucky process might fall in infinite loop forever. might starve forever. Therefore, in this case, the process P2 will just starve forever, right? And other processes, they'll keep on getting the chance. It might so happen, right? Therefore, starvation is definitely possible. Why is starvation possible? Is there is no way a process can say that I am interested, so let me go in, right? So there is no way it can mark anything called as interested or something, right? Therefore, it will keep on falling in infinite loop, and there is starvation. So this, it is starvation free is false. Starvation is definitely there. You might still feel that starvation free, it is starvation free, but then think about this example. Watch it 3-4 times. Next one is the process enters CS in FIFO order. There is no guarantee that process will enter the CS in FIFO order. Why? If it is FIFO order, I mean first in first out order, then P1, then P2 should get the access, right? But there is no guarantee that P2 will get the access. First P1 got the access, then P3 got the access. Again P4 got the access. Therefore, there is no guarantee that they will go in FIFO order. In case if FIFO order is guaranteed, there would be no starvation, isn't it? If FIFO order is guaranteed, which means P1, P2, P3, P4, the order in which the process come, if they enter the critical section in the same order, why will there be starvation at all, right? So FIFO order is definitely not possible. 2 and 3 are actually same, almost same points. Next one is more than one process can enter this critical section at the same time. It is false. Why? Because critical section mutual exclusion is definitely guaranteed because of TSL. Only one process which executes its TSL first will enter the critical section, and all the other processes will get blocked. The reason is, after reading the lock, we are setting the lock immediately without giving any gap in the middle because of the atomic operation. Therefore, no process can enter in the middle and look at the value of lock before it is again set. So mutual exclusion is guaranteed. I told you, right? So only one is it is deadlock free, and mutual exclusion is guaranteed. Progress is not guaranteed, and TSL has to be provided by the operating system, which means it is architecture dependent. Got it?